This is Dr.BDY Sunil, Associate Professor, Mechanical Engineering Department, Institute of Aeronautical Engineering, Hyderabad. In today's session, we will be learning about the problems on screw jack. The outcome of today's outcome is education. Today's topic, course outcome, is apply the static and dynamic friction laws for the equilibrium state of a wedge and ladder applications. And the topic covered would be problems involving frictional force in screw jack. And the topic learning outcome is understand the frictional force and implementation of friction in wedge application. First, let us do a problem on screw jack on screw friction. The problem given is a screw jack has mean diameter of 50 mm and pitch 10 mm. If the coefficient of friction between its screw and nut is 0.15, find the effort required at the end of 700 mm long handle to raise a load of 10 kN. If you observe here, the details which are given here are related to the specifications of screw jack. So the given data which is available in the question is being written here. It is given that the mean diameter of screw jack, that is represented with small letter d, is 50 millimeters, or we can say that the radius of the screw jack can be taken as small r, that is 25 millimeters. The pitch of the screw, that is represented with small letter p, is given as 10 mm. The coefficient of friction between screw and nut, that is represented as mu, is given as 0.15. So from this we can write the friction angle, that is phi, such as tan phi is equal to mu. As we have got the equation tan phi is equal to mu, that is coefficient of friction, we can directly apply this equation to obtain the value of friction angle, that is phi, and it is obtained as 8.5 degrees from the given data of coefficient of friction, which is given as 0.15. And the length of the handle L is given as 700 millimeters, and load to be raised W is equal to 10 kilograms. Right? So the length of the handle, which is represented as small letter L, is given as 700 mm, and load to be raised, that is the total load that the screw jack needs to be raised, which is treated as capital W, is equal to 10 kN. Let P1 is equal to effort required at the end of 700 millimeter long handle to raise the load, and alpha is equal to helix angle that is being given. So from the given data, we can apply the tan alpha equation as P by pi d, which is the pitch of the screw and the diameter of the screw jack. That is the substitution of the values here, that will result as 10 by pi into 50. So that can be obtained from the equation as 0.0637, or we can say that the value of alpha is equal to 3.6 degrees. And effort required at mean radius of the screw to raise the load is given as P is equal to tan alpha plus phi, that is equal to W tan 3.6 degrees plus 8.5 degrees, that is equal to W tan 12.1 degrees. So from this we can obtain the value as 10 into 0.2144, that is equal to 2.144 kilonewton. Now the effort required at the end of the handle may be obtained from the relation P1 into 700, that is equal to P into R, that is obtained as 2.144 into 25. That gives the value of 53.6. So from this, if we simplify the equation, above equation, we will obtain P1 is equal to 53.6 by 700, that is equal to 0.0766 kilonewton, or we can say it is 76.6 newton. So in this way, we will obtain the value. The other question which is given is The mean radius of the screw of a square threaded screw jack is 25 mm. The pitch of thread is 7.5 millimeters. If the coefficient of friction is 0.12, what effort applied at the end of the lever 60 centimeter length is needed to raise a weight of 2 kN? So again, this is related to the screw friction, the problem, and the given data for this from this question can be written like this. The given data as mean radius of the screw R is given as 25 mm. So the total diameter will be 50 millimeters. And the pitch of the thread, that is represented with small letter p, is given as 7.5 millimeters. The coefficient of friction, that is represented with mu, is given as 0.1. Also, that can be equated to tan phi, where phi is the friction angle. The length of the lever, represented with small letter L, is 60 centimeter, and weight to be raised is equal to 2 kilonewton, that is 2000 newtons. From this 60 centimeter, we can convert this to millimeters, as all the units should be in the same standard. So this 60 centimeter can be converted to 600 millimeters. Then the effort, let P1 be the effort required at the end of the 60 centimeter long handle to raise the weight, and alpha is the helix angle. So from this given data, we will be calculating the answer. We know that tan alpha is equal to P by 2 pi r. When substituting the values of P and R here, we will obtain the value as 0.75 by 2 pi into 2.5. So that results as 0.048. And the effort required at mean radius of the screw to raise the weight is P is equal to W tan alpha plus phi. That can be written as W into tan alpha plus tan phi by 1 minus tan alpha tan phi. So from this, we can get the value as, when we substitute the values of the terms, we will get 2000 into 0.048 plus 0.12 by 1 minus 0.048 into 0.12. That is the value which we will be obtaining over P. And further simplification, we will get 2000 into 0.169, that is equal to 338 Newton. Now the effort applied at the end of the lever may be found out from the relation P1 into 60 is equal to P into 2.5, that is equal to 338 into 2.5, which will be obtaining as 845. So from this, if we further simplify, we will get P1 is equal to 845 by 60. That gives the answer as 14.1 Newton. So this is the effort that is needed to be applied at the end of the lever. Now let us do another problem on this friction, screw friction. A load of 2.5 kilonewton is to be raised by a screw jack with mean diameter of 75 millimeter and pitch of 12 millimeter. Find the efficiency of the screw jack if the coefficient of friction between the screw and nut is 0.075. This is the question given. So from this question, the data which we need to consider is given that load, that is represented with uppercase letter W, is 2.5 kilonewton. So the mean diameter of the screw D is given as 75 millimeters. Pitch of the screw, which is represented with small letter p, is 12 millimeters. And the coefficient of friction between the screw and the nut, that is represented with mu, is 0.075. So this can be equated to tan phi, which is the friction angle. So from this given data, we can apply the equation tan alpha is equal to P by pi d, that gives 12 by pi into 75 when the terms are substituted, and that results as 0.051. And efficiency of the screw jack, the equation we have as efficiency is equal to tan alpha by tan alpha plus phi. So that can be written as tan alpha by tan alpha plus tan phi by 1 minus tan alpha tan phi. So that gives 0.051 by 0.051 plus 0.075 by 1 minus 0.051 into 0.075. That results as 0.051 by 0.1265. If we further simplify this, we will be obtaining 0.403. That results as 40.3%. So the efficiency of the given screw jack is 40.3%. So in this way, we will be applying the formula for getting the solution for the friction and screw friction. This concludes the session. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.